Hello everyone, it's September 20th. Let's do this. Design movie rental system. You have a movie renting company and shops. You want to implement a renting system that supports searching for, booking, and returning movies. A system should also support generating a report of the currently rented movies. Each movie is given as a 2D integer array entries, where entries I equal to shop, movie, and price. The system should support the following functions. Search finds the cheapest 5 shops that have an unrented copy of a given movie. Unrented copy of a given movie. The shops should be sorted by price in ascending order, and in case of a tie, the one with the smaller shop, I think that's the ID, should appear first. If there are less than 5 matching shops, then all of them should be returned. If no shop has an unrented copy, then an empty list should be returned. Rents an unrented copy of a given movie from a given shop. Okay. Drops off previously rented a copy of a given movie at a given shop. Drop. Report, return the cheapest 5 rented movies, possibly of the same movie ID as a 2D list. Res, where res is shop or movie, describes that the jth cheapest rented movie. So you have a search, and then you have this report. The report should tell you the cheapest 5 rented movies. The jth cheapest rented movies was rented from shop I at shop J. The movies in result should be sorted by price in ascending order, and in case of a tie, the one with the smaller shop J should appear first. And if there is still a tie, the one with the smaller movie J should appear first. If there are fewer than 5 rented movies, all of them should be returned. If no movies are rented, then empty should be returned. Implement it. So we'll have N is N shops. Entries is for all the movies. And then we don't add new, but we do rent and drop. So the test cases will be generated such that rent will only be called if the shop has an unrented copy of the movie. And drop will only be called if the shop had previously rented out the movie. So there's no error checking. Okay. So what we given, so 3 shops. So rent, shop, movie. So they kind of tell you that you need to have a mapping, right? For each shop, you need to know what movies it currently have, and also the price associated with it, right? And we do drop, we just add it back. But when you add it back, it doesn't give you the price, it only gives you the movie. So you need to have, but the same movie might have different price, right? Yeah, I think the same movie might have different price depending on which shop it is. Look, I think this is exactly what we're saying. It's a shop movie price. So shop movie price, shop movie price, shop movie price, shop movie. So the first movie price at different shops The price is different. But I think this should be unique. We can actually test our hypothesis. I am interested to know if I think there's a lot of probably not a lot, but some things that we don't know. I don't know yet. I don't think I need to do this. So what I want to try is, all right, so in the same shop, same movie, can I have two prices? No. So same shop cannot have two different prices. So that means these three is unique. So can I have, so at different shops, right? At different shops, I can have same price or different price. I think this is also, this should be allowed, because at different shops you can have, yeah, so different shops is fine. It's just the same shop you cannot have the same. Okay. So when you map movie to the price, it's actually, so it has to be movie and movie. Can I have the same? Let's say same shop. I think they said at most one, right? Just double check. Can I have a duplicate? I think it probably cannot. Yeah, you cannot. So yeah, shops, and in each shop you have movie and price. I'm just trying to figure out which one should be the key, which one should be the value. But the search, what does the search do? Search cheapest 5 shops that have an unrented copy of a given movie. So the search is return shops and the cheapest. So I know the movie, right? I know the movie and I have the price, and then I'll return the top 5. I'll return the top 5. Okay? Yeah, I know the movie and I have a price. And I have the shop. So for this, it'll be easy to do movie, right? Price, shop, right? With this order. So when you want a movie, you go to a movie, and if this is sorted, then you get your top. You get your top 5. And then they say if there's a tie, then the one with the smaller shop. One with a smaller shop. All right, I have a question about sorted ordered set. Can I iterate through an ordered set? Yes, you can, and you should. For loop. Explicit iterator. Yeah, that's fine. We can do that. Okay, so that probably will work. So instead of this, I'll have a sorted list, which will have price and shop. right? And they say price should be ascending, and if the price and the smaller shop, yeah, so this is just ascending. This is for this. But rent is different. You can't really do that, right? Because rent is, you have to have a shop, right? Shop, movie price. So shop, if I have movie, but you can only have one price, right? Movie price. This is a shop. This is a shop price. This is a movie price. And drop will be the same, right? Drop will be the same. Drop because you do this. And then you have report as what has been rented. So you need to keep track of what has been rented as well. And the report, cheapest 5 rented movies. Cheapest 5 rented movies. Huh. Okay, what I think is we need to keep something that does not change. There is one that does not change, which is price. So given a movie at a certain shop, it has exactly one price, right? So movie, shop price, and this is static. This thing does not change, right? And then if you want to search for a specific movie, so we can say this, the search will be based on but still you need to update this, like if it gets rented. And then every time you call it, you have to sort it. I am not quite sure about that. What about the constraints? So these are the shops. These are the shop movies. I didn't see a clear-cut solution so far. Cheapest 5 shops that contains this movie. Cheapest 5 shops that contains the movie. Rent drop is fine. I don't really think rent and drop matters that much. Those are just, if you design it well, those should be a O1 operation. Yeah, so basically it's like this is based on movies, right? Based on movies, give me the cheapest file that has not been rented. This is based on the rented, right? Among all the rented movies, give me the cheapest 5 rented movies. And the result, shop and movie. So if you keep track of the rented movies, you will be able to, I think a breakthrough should be rent will always rent the unrented copy of a given movie at a given shop. Because at each given shop, you only have one movie. You won't have 2. We have tried it already. It's only 1. It says at most 1. So when you rent it, that shop doesn't have that one anymore. Right? The shop doesn't have that one anymore. So from a shop perspective, if I do a thing and I say remove, because when you remove the movie and price, these two goes together. So if it's a sorted list, a sorted set, these two can go out at the same time. Right? These two can go out at the same time. And you can do basically you can do a sorted set of movies, right? You sort them by movies. So when you rent, you'll go to that shop and just rent it, you delete it. When you return, you go to that shop and you add it back. Okay? And then all those will be sorted based on a external provided function where you can query the price of the movie. So they're sorted by movie from cheap to expensive. So when you want to search for a specific movie, what you will have is movie will have, because you want to return shops, right? You return cheapest 5 shops. So you'll have the cheapest 5 shops. So now you have shop with a movie, shop with a movie, shop with a movie, shop with a movie, right? And then you have to go through all the shops if you want to see where they are. But if you keep another one with movies, right? With movies, and movies will have shops sorted by the price. So the current data structure is like this. I don't consider this anymore. So we have shops, right? It's going to be this. Each shop will have this. This will be movies. M0, M1, M2. And they will be sorted by price. And then you will have movies. Then you have shop S1, S0, S1, S2. And they're also sorted by price. So when you search for a movie, you go in here, you find the top 5. When you rent, you go to a shop, you remove a movie, and you go to a movie, you remove a shop, right? You drop, you add, and yeah, these two can solve the problem. And we can basically put this as a thing, put price in it. It's totally fine, right? It's totally fine. Actually, it's not fine because you need to find movie. This is a set. You need to find a movie directly. So we do have to prepare a separate, which is a movie to price, right? A movie to price, because that's how we can query. And in fact, dear me, a movie can have different prices. But the movie in a specific shop only have one price, right? Therefore, we can go movie, shop, or shop, movie, price. I think this design is the same. You either go movie, shop, price, or you go shop, movie, price. I think this is the same. It's the same because when you oh dear me, how can you define the search function? Not search function, the order function. It's dependent on this. Because those two are movie and shop, they're together, right? You see, in this shop I have these, because when you define, you have to define exactly what. So you have to put shop in this. So this has to be a pair, a shop and movie. This has to be a pair, a shop and movie, right? A shop and movie and shop and movie. It's just, so essentially these two are the same thing. Well, not exactly the same thing, but there is the same value. And this, once you sort, you can use this to get the price. Okay, so I think this can solve these two problems. You can solve this because you can go to the movie, right? You go to the movie, find the top 5. You can get this, you can get this report. Report needs to report the cheapest 5 rented movies. So when you rent, you need to keep track of another thing, which is rented movies. So rented movies, you can do shop movie. Exactly. It actually tells you what it needs to be. You can have shop movie, and this will be sorted based on price as well. Now I see. Okay. It's actually giving you a lot of hint in the problem already. But I do think this one will probably take a little while to implement. Okay, I'm putting on my glasses now, so let's go ahead and then do this. Okay, so what do we need? We need, we have to do a private. It's misspelling. All right, so we need a, doesn't matter, shop movie price and movie shop price, it doesn't matter. So it's gonna be this is gonna be an unordered map, which is int, and a unordered map, which is int and int, right? So it's, well, let's just call it shop movie price map. Okay, and then we need a unordered map again, right? But this time it's gonna be a sorted, just a set of pair. This is gonna be this one, our shop to shop movie. Shop to shop movie map. Okay, this is a shop movie price. This is shop to shop movie. Okay, and the last one is exactly the same. I'm gonna do a set pair. This will be movie shop movie map. This is a movie to shop movie. Yeah. Right, this is a movie to shop movie. Okay. So a set is, how do we customize? Customize sort in std set. There gotta be a way. Set comparator. We'll use lambda. This. Okay. It's about the same. So here, I don't know what n can help us. Like, no, I don't know. What can n do? We have entries, right? We just go through all of them and then put them in the stuff. So we say std for const auto this entry of entries, right? So what do we have? We have shop movie price. So I have shop equal to entry 0, movie entry 1, and price entry 2. Okay. Then what? And then we say shop movie this shop movie equal to price. Ooh, we have to do two inline here. Oh my goodness. The inline is the same. Inline static auto comp equal to const auto p1 const auto p2. We probably need this one to happen after this one is defined. Okay. So we'll compare, right? Oh, I don't have to, right? Because we say if, oh, we might have to reverse them. The shop shall be sorted by price in ascending. So price goes first. So price goes first and then shop. Dear me. Price goes first and then shop. Price goes first and then shop. Yeah, it should be price goes first and then shop. My bad. And if we do that, we don't have to do this. So this should be, oh, my bad. It's very different. This is a shop and movie. So price go first, right? So if P1 dot first is a shop, All right, I think it'll be easier if we just say, we can say shop1 p1 dot first. Why do you say const auto? I have no idea why I said that. All right, so p1 first movie 1 p1 dot second s2 p2 dot first m2 p2 dot second. I'm actually not sure if that even matters. So it's price and shop, right? Price, so it should be price, shop, and movies. Price, shop, movies. Yeah, price, shop, movies. Yeah, price, shop, movies. And the search is giving you a movie, so it's price, shop. Report is price, shop, movie. Yeah, so price, shop. Now we have to get a price. So p1 shall equal to SMP map. This is shop. So shop 1, movie 1. Right, and p2 is SMP map shop 2 movie 2. Okay. Invalid use of non-static. All right, let's go static then. Oh, p2. Oh, I cannot use p2. I have to use pair 1 and pair 2. Ah, screw it. A and B. Okay, this is gonna be A. This is gonna be A. This is gonna be B. This is gonna be B. And then So we'll compare price first. So if P1 is equal to P2, we'll do something. Else, don't need to else, we should return P1 smaller than P2. So if it's the same, if shop 1 is equal to shop 2, then we will return M1 smaller than M2. Otherwise, return P1 smaller than P2. No, not P1 smaller than P2. So S1 smaller than S2, shop 1. So it's basically if the price is the same, I'll compare shop. If shop the same, I compare movie. And if shop is not the same, I will return a smaller one first. Otherwise, I return a smaller price first. So with that, and then unordered map, the set here, declare type comp. Here's the same, declare type comp. Okay, so that's that. So we'll have now the comparison is dependent on the price. So I need to get the price first and then I start inserting them. I think that's a good idea. So I'll do this first because it's depending on this. After I finish this, then I'll go through this one more time because I do it twice, right? Entry is actually important of entries. So we'll copy this line. Okay, so now what we can do is we say SSM map shop dot add push insert insert shop and movie. Right, I don't even need price in this case. And we have movie, shop, movie, map, movie, right, that insert shop, movie. Okay, now search for the movie. So we go to movie, right, we go to movie, and then we just say top 5 int count equal to 5, and then for and I will return the shop, right, return the shop. So we say for const auto p of movie sm map movie. We'll have the result vector rest.pushback p dot first as a shop, and then count minus minus. If count is equal to 0, return, not return, break, and we'll return result. Okay, that's that. Oh, we also need a rented. Oh my goodness. So I also need rented a set of pair declare type comp rented. So rent, we'll go to the shop, right, we'll go to the shop and we'll say const auto pair are equal to go to what? Shop this map. What do shop? It's the same, right? So from shop. No. I have the pair. All I need to do is, oh shoot, I cannot. Can I do pair in a set? Yes, I can. Pair can be in a set, a sorted set. So what we need to do is, I have that, so I should do pair shop movie, right? Int shop movie equal to shop movie. Can I just remove that? I'm not sure, but rent means I will go to mp sm map shop dot erase this, and then this shop dot erase this, and then rented dot insert this, that's rent, drop rented dot erase, we'll do this one again. So beyond this, or remove this, and map shop dot insert this and this movie. Oh, that's not shop. That's movie. Insert this. Okay, so this is a report report says we want to return the 5 cheapest. So again, count equal to 5, equal to 5, and then we'll go through rented. Right, we'll go through rented, and then we say vector res for const auto this of rented. I like to use p. So I'll have because it's already sorted, so I can just grab it. Maybe there is that pushback. I can probably do it in place back, but yeah, p dot first. Ooh, yes, p dot second. And we'll return res. And count minus minus. If count is equal to 0, break. All right. All right, I am going to test this. Undefined symbol. Where? Undefined symbol. Maybe here I cannot use it. Undefined symbol. I think I probably need to take by reference here. Non-local lambda expression cannot have a capture default. Then how do I capture it? All right, ask Gemini. I want to define a an ordered set with a custom comparator. The comparator in a private member. The comparator needs to take a reference of another private the reference of a map that is another private member. How can I achieve this? Currently, I'm getting this error. Alright, let's see. A lambda used to declare a member variable cannot capture anything from its surrounding scope. A lambda's capture list can only capture local variables, or this, if it is defined within a function or another block. To solve this, you can define your custom comparator as a nested function object, or by capturing this. Oh, I can capturing this. Let's see, this one they say is the recommended way. So private, I have a map, I have a struct, define the custom comparator as a private nested struct. The struct constructor takes a reference to the private map. This is a map reference. This map reference M pass the private map to the comparator's constructor. Holy crap. Okay, how about this? Use a lambda in the constructor capturing this. That's okay. Custom lambda comparator type used for declaration. That's fine. Oh. So you define it inside the constructor. Define and pass the lambda comparator in the constructor. You pass in this, you capture this. My set so you pass this to the set. Oh, but my set, okay, this is actually not gonna work. I think I have to use this. Actually, I don't know how it's gonna work because. Alright, okay, my use case is a bit more complicated. My set is actually inside another map. Like this. Unordered map set pair. How can I declare the map using a custom comparator for the set as its value. Alright, I think I'll stop right here because this is going to take a while for debugging basically C++ implementation side. But I'll see you guys tomorrow.